In this video, we're going to do another example of finding local extrema of a function of two variables. We're given the function f of xy equals y cosine x. We're asked to find the local extrema and or saddle points of this function. So we'll take our partials with respect to x and with respect to y. With respect to x, we get negative y sine x. With respect to y, we get cosine x. Looking at our partial with respect to y, we see that that partial is equal to 0 when x is equal to pi over 2 plus n pi. Looking now at our partial with respect to x, we see that it's 0 when x is equal to n pi, but that doesn't make the first partial with respect to y equal to 0. So these x equal to n pi isn't going to give us any critical values. So the only thing that will give us, critical points, the only thing that will give us critical points is when y is equal to 0. So that's why our only critical points have the form pi over 2 plus n pi, comma 0. So we take now our second partials. The second partial with respect to x is negative y cosine x. Mixed second partial is negative sine x. Second partial with respect to y is 0. Notice that if we put the critical points in for the second partial with respect to x, we always get 0 because we're putting 0 in for y. And of course, our second partial with respect to y is always 0. So our a and our c value are 0 no matter what. For the b value, when we put in pi over 2 plus multiples of pi, sine will be 1 if that n is even, and then it will be negative 1 if n is odd. And of course, we got the negative out in front, so it flips the sign. So if n is even, we get b as negative 1. If n is odd, we get b as 1. However, it doesn't really matter because we're going to square the b anyway. So in any case, when we do this computation for our d, at every single critical point, we get a negative 1, which is negative, of course, which means that pi over 2 plus n pi comma 0 yields a saddle point for every single critical point. So all we get are saddle points here. And if we look at the graph of this, we see that we really do get saddle points. These are not, the surface is cut off, so these are not maximum. It would continue to go up. We see all of these saddle points all over the place. So that's the only type of extrema we get in this particular example.